In this lesson, we shall focus on the Gauteng Province Preparatory Examination of 2023 Mathematics Paper 1. It was written in 3 hours out of 150 marks. It is Mathematics Paper 1, written in September last year. And we're getting started and we're going to solve the questions together. Right, in the first question in the Gauteng province, question 1.1.1, the learners were asked to solve the first question. They were asked to solve 2x plus 1 all squared minus 4 equals 0. What do we do here? Anyone? What do we do here? What is the first step?
Sir.
Yeah, anyone. Either Pehelelo or Nombuso. Doesn't matter.
Okay. It's Nombuso, sir.
Okay, so that's fine. Okay. Yep.
We are going to expand the 2x plus 1.
If you expand it, what do we get?
Okay, we are going to make it 2 because it's squared.
Yeah, okay, because it's squared, we can write 2 pair, a pair of brackets like this and another pair of brackets like this, and then minus 4 equals 0, right?
Yes.
And then we use the FOIL method. Right, we multiply 2x and this, you multiply x and that, you multiply this with that, you multiply this with that. So if you multiply 2x times 2x, what do we get? We get exactly 4x squared.
4.
Good. Yes. 2x times 1, we get 2x. Then 1 times 2x, we get 2x. And then 1 times 1, we get a 1, and we subtract 4, and we get 0. And from this, we get 4x squared. 2x plus 2x gives us exactly 4x. 1 minus 4 gives us minus 3 equals 0. Right, and at this point, we're able to see the factors. What are the factors of this? So what are the factors of 4x squared plus 4x minus 3 equals 0? What are the factors?
It's not 2 and 1. 2 and 2.
Yes, 2 and 2, yeah. Okay, so in other words, we have 4x squared plus 4x minus 3 equals 0. Then right now, we need to get the factors of this. Okay, now to easily get the factors in a situation like this, you multiply 4x squared times minus 3. Right, so when you multiply 4x squared times minus 3, what do we get? We get exactly minus 12x squared. And at this point, when you get minus 12x squared, you look for the factors of minus 12, which when added together will give 4x. Factors of minus 12x squared, which when added together will give 4. And those factors will be 6x together with minus 2x, because 6x times minus 2x will give us minus 12x squared. Yet 6x minus 2x will give us what? Plus 4x. And therefore, we're going to write here 4x squared plus 6x minus 2x minus 3 equals what? 0. And we pull out the highest common factor, something called the highest common factor, the HCF. HCF. Right, and then here we're going to pull out the highest common factor. The highest common factor of 4 and 6 is what? It's a 2x. Right, and then now if we have this, we have also here another 2x. Then here you're going to have a 3. If you pull out, okay, if you pull out the highest common factor 2, then you say 6 divided by 2, you get a 3. Okay, obviously the x has been pulled out. You factor out the negative and you have 2x plus 3. Okay, you need to repeat and repeat this method. It's not very popular, but it's the best way to factorize. So you have 2x plus 3 is here. So because the 2x plus 3, you pull it out, then if factor it out, it's a common factor. You are left with 2x minus 1 equals 0. Right, and at this point, when you get to this, you can see that x is minus 3 out of 2, or x equals what? 1 out of 2. And therefore, this becomes the answer to this. Any question? Any question?
Say,
Yes, please.
Mina, I did it with
Quadratic.
quadratic.
Yes, you can use the quadratic formula. It's okay. Any method, as long as you get the same answer. The quadratic what? Formula. What is the quadratic formula? X equals minus b plus or minus the square root of b squared minus 4ac out of what? Out of 2a. Right, so that is what we're getting exactly. So next, we actually going to do the thing. But you see, this one can also be done differently. I mean, another kid can come here and say, I can see that it is this squared. I can move the 4 to the other side. Then the kid can realize that, okay, at this point, you have 2x plus 1. You square the 4. And then you have plus or minus the square root of 4. And then the square root. We have now, then you take the square root both sides. The square root of 4 is plus or minus 2. And then we have 2x plus 1. Then the kid can come and say, okay, 2x plus 1 is 2. Or you can say that 2x plus 1 is a minus 2. Okay, so yeah, you can have that. 2x plus 1 is 2. Or you can say that 2x plus 1 is what? Is minus 2. And then this means that 2x is 2 minus 1 is a 1. 2x is minus 2 minus 1 is a minus 3. You divide by 2, which is 1/2, or you divide by 2, which is minus 3 over 2. Okay, we got 1/2 and minus 3 over 2. And here we also got 1/2 or minus 3 over 2. So in other words, both methods work correctly. Both methods work correctly. So now we look at the next question. This one here. We need to solve 4x squared minus 11 is equal to that. So this is that plus 12x minus 11 equals 0. And at this point, then to use it, because once I say correct to 2 decimal places, you just need to use the quadratic formula. So you have minus b plus or minus the square root of b squared minus 4ac all over what? 2a. The a is 4. The b is 12. The c is minus 11. So you're going to say minus b, which is minus 12, plus or minus the square root of the b squared. The b squared is actually exactly 12 squared minus 4a. A is what? A is 4. Right, and then c is minus 11. All divided by what? By twice a, and a is 4. And this is minus 12 plus or minus. Okay, so we're going to use our calculator to do this one. We're going to use our calculator to do this. So now what we're going to have here, we have 12. 12 squared minus 4 times minus 11. You close the bracket, and what is the answer here? Then you have exactly 300 and what? You have exactly 320 under the square root. So in other words, you'd have exactly 320 under the square root. So you have the square root here of 320. You divide everything by 2 times 4, which is what? which is exactly 8. So that you have minus 12 plus the square root of 320 divided by 8, or x equals minus 12 minus the square root of 320 divided by 8. So that now you continue to use the calculator. By using the calculator, you actually are able to obtain the following. So you can do this and punch minus 12 plus the square root of 320 divided by 8. Right, and therefore what we're getting here is that answer, which is 0.74. 0.74. Right, so here you have x is approximately 0.74, but obviously they set to 2 decimal places, so 0.74 or x is approximately, so you're going to do this one here. So that now you come here. So that in the end, this one is minus 3.74, minus 3.74. So we also have minus 3.74, and that becomes the answer to the 11 point what? To the 1.1.2 question. Okay, I know that the quadratic formula is known very, very well. Where's the question about this one? No question. We move on to the next question. Okay, please try 1.1.3. Right, 1.1.3 is 15x minus 4 is less than 9x squared. Please try this question. Let me know when you're done, and then we shall do the corrections together. Try 15x minus 4 is less than 9x squared. Try it there in your book. I'm giving you like 2 minutes. And then please, when you're done, let me know. When you're done, let me know. When you're done, let me know. Right, when you're done, let me know. When you're done, let me know. How far? Okay, now this one, you need to write it in what you call the standard, in standard form. So you have 9x squared plus 15x minus 4 is less than 0. You bring the 9x squared to the other side. And then the next thing is, because the 9x squared has a negative, you'll have to multiply the left by -1. Right, so you have this here, minus 4, but now you need to also multiply by -1 the 0. The inequality will change direction. When you multiply by a negative number both sides, the inequality changes what? Direction. Okay, and at this point, you have what? You have negative times negative, which is positive. 9x squared minus 15x plus 4 is bigger than -1 times 0 is actually exactly a 0. So what are the factors of this? So to get the factors, you take the 9x squared, you multiply it by 4. Right, so if you have this one, you multiply it by 4, what you're getting here is actually exactly 36x squared. Right, and upon therefore careful examination, what we have is then the following. Yes,
Oh,
please.
okay.
What do you think?
No, I'm saying I'm done. And
What answer
yeah.
did you get? What answer did you get?
I got 4/3 and 1/3.
4/3, 1/3. What are the inequalities here? Is it less than? Is x less than or greater than?
It's okay. So I said 1/3 is less than x, and 4/3 is greater than 4/3.
Okay, let's write your answer well, because we're just going to compare now with the answer we're going to get. And we're coming to you, please, Pegelelo, as well. We are coming to Pegelelo. Right, you said, what is the thing? I need to write down exactly what you're saying.
Okay, I said 1/3
1/3
is greater than or equals to x. Sorry.
is greater than or equal to
Yes,
x, like this,
it
okay?
is greater than. It's less than. I'm sorry.
Or it's less than, okay? So it's less than x,
Yeah.
like this, yeah? And then
Yes.
did you say now the 4/3?
Or equal.
Is it less than or equal to 4/3?
4/3 is yes.
Okay, is it like this, or
Even on 1/3.
even here there's something like this?
Yes.
Okay, that's fine. Remember, we're practicing. Okay, good, thanks. So you need to factorize this, and you want to check if your answer is correct. So we need to obviously look at this. And once again, this lesson is recorded. Even if your network is bad, but you're going to get the recording at the end of the day. So now we multiply to factorize this easily. You multiply the 9x squared, the quadratic term, by the 4. Then you get 36. And upon careful examination, you look for two numbers, the factors of 36, that give minus 15. Right, there are two numbers, which when you multiply, you get 36. But when you add them up, get exactly what? You get exactly 15. Right, now the question becomes, you get minus 15. What are those numbers? So obviously you need to sit down and think, but now think very, very carefully. Right, what are the factors of 36? Which when added together will give minus 15. Right, so you need to think, but think very, very carefully and reason. So now you need to work out the factors of 36. For instance, you would see that the factors of 36 would be 4 and 9, but 4 and 9, when you add them up, they did not give minus 15. Right, and then now you can actually be in a position to break these, to separate these, for instance, and then you can look at 3 times 12. Right, 3 times 12. So you can see that, okay, if you take minus 3x and minus 12x, okay, minus 3 times minus 12 will give you 36. Obviously, with the minus 3x minus 12x will give you exactly 36x squared. But when you add them up, you get minus 15. So that at this point, you have exactly 9x squared minus 12x minus 3x plus 4 is bigger than 0. Right? So now if you think these are the numbers, then you take the highest common factor of the 9x squared and the minus 12, and you get a 3x. And then here you'd get exactly a 3x minus, and then you have a 4 here. Right, and then here you pull out a negative, you have 3x minus 4 is bigger than 0. Which means, therefore, that at this point you take the highest common factor. So you cross this out, and then you have 3x minus 4 and then 3x minus 1 is bigger than 0. So these become the factors. Right. So now upon careful examination, what you need to do, you need to draw a rough sketch. So you need to find what you call the critical. You need to find critical values. What are the critical values? The x equals, you put equal signs, you put 4/3, x equals 1/3. So now you have the minimum vertex like this. And then you have 1/3 and you have 4/3. Like that. Okay, this graph is going to have a minimum vertex because the coefficient of the quadratic term is positive. And therefore, now you need to read off the answer. And to read off the answer from this here, you need to note, therefore, that we're looking for where the quadratic is positive. And the quadratic is positive where? The quadratic is positive exactly there. And the quadratic is positive above. Right. And therefore, it means that your x is going to be less than 1/3. Or x is going to be bigger than what? Or x is going to be bigger than 3 because we're going to look at this arm when it's bigger than 4/3, or x is less than 1/3. Okay, so this is the answer to the question. Where's the question?
So say
Yes.
mine is mine is wrong.
Okay,
Or what?
okay. Oh, yeah, okay. You see, what you need to look at is that when the inequality is strict, it's a strict inequality, like it's less than. So obviously here we need to remove anything. So we can't make it equal to, you know. If it's like here, it's less than only. So we can only deal. So we can't make it like this. We can't make it like this. If it is only this, then we can't make it this because it's only that. So it's only less than, so we can't make it less than or equal to. You get the point?
Yes, sir.
Yeah. Okay. Yeah. So that's
say,
yeah.
you said, okay, you said x greater than 1/3 or x, yeah. So I'm confused on or.
Yes, or the or is because it's separate. These you are looking for where the inequality is greater than 0. Greater than 0 means the quadratic is greater than 0. If it's greater than 0, then we're looking at greater than 0 means above the x-axis. This is the x-axis, and therefore we are saying above the x-axis. And therefore we're going to take this this solution here where it is above. We're going to take this solution here also when it is what? When it is above. And therefore it means that we shall have here our x less than. Why is x less than 1/3? X is less than 1/3 because we actually, this graph is actually going higher and higher when we are moving towards less than the 1/3, but also when we are moving towards the greater than. So x is bigger than 4/3 when we are moving upward like that.
So what if, say, you treat your graph either
Either like this. Right, yeah. So obviously at this point, we made the graph like that because it's because of this. Because of the fact that the 9 is what? The 9 is positive. The 9 is what? Is positive. You see, because the 9 is positive, then it is going to have a it has a minimum vertex. Right, it has a minimum vertex, and therefore it will pretty much be this. Obviously, it can only be this way when you have a negative coefficient here. But for us to factorize with ease, with simplicity, then we must make sure that the coefficient of the quadratic term is positive whenever we're writing the equation in what? In standard form. What is the standard form? The standard form is ax squared plus bx plus what? Plus c. This is called the standard form of a quadratic equation. And obviously, this is going to be the standard form of a quadratic expression. Any question? Okay, so try to think about this. Try to think about this. Okay. Pegalelo, any question?
No, sir.
Okay, we move on. Okay, the next one is 1.1.4. Okay, in case you get disconnected, please join again because you might get disconnected. If you get disconnected, please join again. Okay, this one, how do we solve this one? Pegalelo. Right, we need your input. How do we solve this one here? How?
So are we gonna look for the common factor?
Okay, that's fine. We're talking about 1.1.4, where we have the square root of 2x minus 2 minus the square root of 7 minus 2x equals 1.
Oh, we're gonna remove the square roots first
How are we going to remove it?
by squaring them.
By squaring both sides.
By
Okay?
brackets. Yes.
Good. Right, so we square both sides, and this one you know very well. Now to square both sides, first things first, that is correct. So well done for getting that one right. So you're gonna have one square root, and then if there are two square roots like this, we need to move one square root to the other side of the equation. So we're gonna take the square root of 7 minus 2x to the other side, and then you add a 1 like that. So that then in the end, you have 2x minus 2, and then we square the left, and then we have the square root of 7 minus 2x plus 1, and then you square like this. Okay, obviously you square both sides. If you square both sides, then it becomes exactly 2x minus 2 is equal to, now if you square this one, you square the square root, it becomes 7 minus 2x. And then we have this times 2, which is 2 times the square root of 7 minus 2x. You square the 1, you get a 1 like that. Right, and upon careful examination, we're going to add all the terms out. Right, so we add all the terms out. We would have the 2x, and then we add these 2x. So it's going to be exactly what? 4x. Then we collect like terms right now, because now we know that 7 plus 1 is 8. Minus 2 minus 8 is going to give us exactly what? Minus 10. And this is equal to 2 times the square root of 7 minus 2x. We square both sides. Now we have 4x minus 10. We square the left, but before perhaps we square, what we can do is we can divide right through by 2 to simplify this. So we have 4x divided by 2, you have 10 divided by 2, you have 7 minus 2x divided by 2. And then we have 4x divided by 2, you get 2x minus 5. And this is exactly 7 minus 2x. And when you get to this point, we actually have been able to write it like this. And we have the 2x minus 5. We square the left, 7 minus 2x. And we square this. So that now when you square this, it becomes exactly 4x squared. Now the 2x times minus 5 times minus 2, 2x times minus 5 is minus 10, times minus 2 is actually minus 20x. You square the negative 5, you get actually a 25. You square the square root, it becomes 7 minus 2x. You collect like terms, and this becomes exactly 4x squared. You have minus 20x plus 2x, which is actually minus 18x. And then we have 25 minus 7, we have plus 18 equals 0. Like that. So that then in the end, you actually need to simplify this. To simplify this, you divide right through by 2. And divide 4 by 2, you get actually exactly 2x squared. You divide the minus 18 by 2, you get 9x, and you get plus 9 equals 0. Now, when you get to this point, you need to factorize this. So if you have exactly 2x squared minus 9x plus 9 equals 0, how do we factorize this? Now, to factorize this here, you multiply 2x squared by 9. And if you multiply 2x squared by 9, what do you get? So you take 2x squared, you multiply it by positive 9. And if you do that, you get exactly 18 x squared. You look for the factors of 18x squared, which when added together will give a -9. What are the factors of 18, which will give exactly -9 when added together? Right, so you need to think of this. And those factors are -6x together with -3x. Right, because -6x times -3x will give us will give us plus 18x squared. Yet if you add -6 and -3, you get actually a -9. So that here you get 2x squared, you have a -6x, you have -3x, so you add a 9, you get a 0. Pull out the 2x like this, you have exactly the x -3 -3, then you have x -3 equals 0. And upon careful examination, you actually will need to take out the highest common factor. So this one you cancel out, and then it is x -3, which is 2x -3 equals 0. And upon careful examination, what are you able to get out of this? You're able to see that x is equal to 3. X is equal to 3 out of these, or x is equal to 3 out of 2. Right, so you get these particular solutions. And then right now you need to check the solutions and realize if you test, this one is not applicable and this one is applicable. How do you know this one is applicable? It's not applicable. It is not applicable because when you put it here in the place of the x, you're going to have actually a problem. What problem are you going to have if you put it here, for example? In the place of the x, you substitute, you put a 3/2, 2 cancels, it gives you 3 minus 2, which is a 1. And then, so you get a 1 on this side. You get a 1 on this side. When you put the 3/2 here, the 2 cancels, giving you 7 minus 3, and 7 minus 3 is a 4. And then the square root of 4 is what? The square root of 4 is actually exactly 2. 2 plus 1 gives you a 3. And what you're getting is that 1 is equal to 3, but 1 is not equal to 3. And therefore, the x is actually, this x equal to 3/2 is not applicable. And in other words, what you then say in the exam is therefore that you reject. Right, so you reject. What do you reject? You reject this solution, or you can say, you can then say that x is not equal to that. You can say that x is not equal to 3 out of 2. You can say x is not equal to 3 out of 2. Any question?
Say,
Yes.
can you please repeat for me this one, yeah, 2 square root of 7 minus 2x.
Let me see. You're saying the 2 square root of 7 minus 2x.
Yes.
This one, 2 the square root of 7 minus 2x. Okay, that's fine. Okay, here we collect like terms. So to collect like terms, please come again.
Please, can the up one over there?
This one,
No,
this one,
next to it. Say
this one.
yes.
Okay. Right, because okay. Remember that we're given the square root of 2x minus 2 minus the square root of 7 minus 2x is equal to 1, right? So what we did was we moved this one to the other side. So always when you're given 2 square roots in one equation, you move one square root to the other side so that you are left with 1 square root on one side of the equation. At this point, now you start squaring both sides, and you square both sides, squaring 1 square root on the left and are now squaring the right also. And when you square the left, you'd have actually then 2x minus 2. And then on the right, you square the right. And when you square the right, you're going to have exactly what? Right, when you square the right, you square this square root. You square this square root. And so when you square this square root, what do you get? You square this square root. So you get 7 minus 2x plus. Then you multiply these times 2. And then it becomes 2 the square root of 7 minus 2x. Then you square the 1. Like that.
Oh, you multiply.
Yes, just multiply. You see, like
Okay.
in the same way that you square x plus y squared. What is the answer to x plus y all squared?
The answer is x squared plus y squared.
Okay, yeah, the answer is going to be x squared plus 2xy plus y squared. All together.
Oh, yeah, okay.
Yes, so it's the same.
Oh, yeah. Yes.
Yeah, so it's the same. So you square this, the square root, and then next to square a binomial like this, which is a 2-term expression, you square the x. Then next you multiply x and y times 2. X times y times 2, you get 2xy. Then you square the y, it becomes what? Y squared. Are we together? So in the same way here, when you are squaring, you will square first this one. And when you square the square root goes away, and you're only left with 7 minus 2x. Then the next thing is it is these times 2, which is 2 the square root of 7 minus 2x. And then you square the 1. 1 squared is 1. Then now you have the 2x. And then you also have minus 2x. And now you collect like terms. Now this 2x is negative 2x, but when you bring it to the other side, it's going to be positive 2x. Or it's going to be plus 2x. And then now you have 2x plus 2x. What is 2x plus 2x? It's a 4x. Then now you have here the 7 plus 1, which is 8. The 8, when you bring it to the other side, is going to be negative 8. Now you have minus 2 minus 8. What is minus 2 minus 8? It's minus 10. And then now we can see here there is a 2 here. And so we can just divide both left and right by 2, because we can see 2 goes into 4, 2 goes into 10. So you can divide by 2. And you divide by 2, you have 2x divided by 2, 4x divided by 2, you get 2x. And then you have minus 10 divided by 2, you have a minus 5. And then you divide the 2 by 2, which is a 1. And then now we have the 2x minus 5 is equal to the square root of this. Now we have 1 square root left. And then you square both sides to remove the square root that is left. And then you have 7 minus 2x. 4x squared minus 20x plus 25. And then we have 4x squared minus 18x plus 18 equals 0. And then now you can divide through by 2 here, because 2 goes into 4, 2 goes into minus 18, 2 goes into 18, and you get this. And then now you just need to factorize this, the 2x squared minus 9x plus 9. You just need to factorize and get x equals 3, or x equals to 3 over 2. So that is the answer. We move on, right? Okay.
Yes, sir.
Okay, good. Let's move on. Okay, if you get confused, please ask, because we're just revising the paper of last year. Okay, now the kids of last year, when we wrote the preparatory paper of September last year, they had to solve the following equations simultaneously. So now they gave them these simultaneous equations. So the question is that what are these simultaneous equations, and therefore what are the answers to this to these simultaneous equations? Now, obviously, a couple of things that you need to take into account here, because now when you're given these simultaneous equations, you're given the log. You're given the log base 2 of a plus 5 is equal to what? Is equal to 3. So you can take this one like this, which means a plus 5 is 2 to the power 3. What is 2 to the power 3? Is 8. Then you have a plus 5. And therefore now you have 8 minus 5. 8 minus 5 is equal to 3. So you got already one of the solutions. Because you need to solve this equation simultaneously, then you have the other equation now. Now you're going to come here and then say the a squared b squared. A squared b squared minus 2ab minus 8 equals 0. So that the a is 3 squared, then you have b squared minus 2. Right, so you have minus 2, the a is 3, the b minus 8 equals 0. So that now you square the 3, you have a 9b squared minus 6b minus 8 equals 0. Right, so you have this particular equation. So what equation have we got? Right, now you have exactly 9b squared minus 6b minus 8 equals 0. Then you need to factorize this. What are the factors of this? Right, to get the factors of this, you need to multiply minus 9 or 9 by minus 8. And if you do it, you multiply the 9b squared, you multiply it by minus 8. Then this is minus 72b squared. Minus 72b squared. Okay, if you have minus 72b squared, what are you going to do now? You look for the factors of minus 72, which when added together will actually give, for instance, a minus 6. Right, so you maneuver the factors and such that you're able to get a minus 6. And so what are those factors? Right, one way to get the factors with so much ease, you know the factors of the 9b squared, they are 3b together with 3b. The factors of minus 8, they are 4 and 2, or 2 and 4. Right, so now, or you can use also 1 and 8. Right, so at this point now you multiply, and for instance, if you check your 3 times 2, it's what? Your 3 times 2 is a 6, and then here your 3 times minus 4 is a minus 12. Minus 12 with 6b. Right, and therefore, if you add this one, so still the minus 12b and the 6b, they give you minus 72. Yet when you add them up, the minus 12b and the 6b, they give us minus 6. So that in this case, then you have this one, you have minus 12b plus 6b minus 8 equals 0. Right, and then you take the highest common factor of the 9 and the 12, and you'll get that it's what? It's exactly 3b, and then you have 3b minus 4. And then here you pull out the highest common factor, which is 3. And if you pull out the highest common factor, which is 2, excuse, right? So you pull out the highest common factor, which is 2 out of this. And if you pull out the highest common factor, which is exactly 2, then we have exactly 3b, 3b minus 4 equals 0. And then now at this point, you can see that the 3b minus 4 is common, is the highest common factor. So you pull out 3b minus 4, and then you are left with 3b plus 2. This equals 0, which means that b is 4 out of 3, or you have that b is minus 2 out of what? Minus 2 out of 3. So that is the answer to the question. So take a look at this very carefully, and therefore this is the solution. Where's the question here so far? Where's the question here so far? Any questions? So the solutions are a equals 3, and then here you have exactly b equals 4/3, b equals minus 2 out of 3, like that. All right, any question? Where's the question? Okay, in the absence of a question, we move to the next one. We move to the next question. So please, you need to pay attention and follow. Okay, if you look at 1.3, in 1.3 now, you are saying you need to deal with this. If P is equal to, if P is equal to the square root of x plus 2 divided by the square root of 16 minus x squared. If P is this one, for which values of x will P be real? For which values of x will P be real? So now at this point, try this one, please, for 4 marks. Let me know when you're done. I'm giving you like 2 minutes. Pehalelo and Nombuso, please try 1.3. For which values of x will P be real? Okay, try it. Try it. Right. Please try it. Right. Let me know when you're done. Please let me know when you're done. Let me know when you're done. Please let me know when you're done. Please let me know when you're done. Pekalelo, how far are you?
A bit far, but I'm getting there.
Okay. Nombuso, how far are you?
Almost done.
Okay. Okay, right. For the sake of progress, because we do not have the whole day, what you need to take note of is that obviously we just have 2 hours online. So we're going to take the x plus 2 in this expression. We take the numerator. The numerator must be greater or equal to 0 because we have a square root. So if you have a square root, you need to make sure that whatever is under the square root is greater or equal to 0. But simultaneously, then whatever you're going to have is the fact that the denominator itself, which is 16 minus x squared, must be what? 16 minus x squared must be greater than 0. Right, so that is what you need to have. So you must have this, and then you put and like this. The 16 minus x squared must be greater than 0. Okay, so that then in the end, we have x is greater or equal to minus 2. And this one, now you need to find the factors of this. What are the factors of this? Right, the factors of this are 4 minus x together with what? Together with 4 plus x, this is bigger than 0. Because this one is quadratic, you need to find the critical values. The critical values are x equals 4, x equals minus 4. So that then in the end, what you're able to get out of this one is quadratic. So because the x squared has a negative coefficient, it's going to have a maximum vertex like this. And you're therefore going to put the minus 4 here with the 4. And upon careful examination, when this is greater than 0, you would realize, therefore, that you actually would open like this. And this goes up. So you're going to consider the part where it is above. So it's all this part here that is above the x-axis. And therefore, from this, we're able to see that minus 4 is less than x less than 4. So this becomes a solution because it is when x lies between minus 4 and 4, x lies between minus 4 and 4. That is when you have that this graph itself is bigger than 0. And therefore, you have x. So you need to get the solutions now. This one, so you have minus 4 together with 4. And then you have minus 2. Minus 2, x is greater or equal to minus 2. And then here, this one here, okay, this one is a strict inequality. It's not equal to 0 because the denominator cannot be equal to 0. We do not divide by 0. Division by 0 is undefined. So make sure that for this to be the square root, anything under the square root must be bigger than 0. So, but here we're saying it's strictly bigger than 0. Why? Because we can't say greater or equal to 0. Why? Because we don't want to divide by 0. And then in the numerator can be 0, so that the x plus 2 is greater or equal to 0. So that then in the end, then we have minus 4 to 4. Right, so now you're going to have the minus 4 to 4. Right, so you have exactly minus 4 to what? To 4 like this. So when then do we have an overlap, because there's an end here. This end means we need to look for where these things overlap. So these particular two lines, they overlap here. So which means that in the end, our solution is going to lie between these two. And it means that our minus 2 is less or equal to x is less than 4. Minus 2 is less or equal to x is less than 4. Minus 2 is less or equal to x is less than 4. So that is the answer to this question. Right. That is the answer to this question. Right. Where's the question? Any question? So in other words, for which values of x will p be real? Real means that avoid the denominator from being 0. So you need to take the 16 minus x squared and make it strictly bigger than 0, but also simultaneously the x plus 2 must be greater or equal to 0. Why? Because we have a square root. The things under the square root must always be greater or equal to 0. We're taking the square roots of things that are greater than 0 of numbers that are positive. Where's the question? Right, in the absence of a question, we'll move on to the next problem. Okay, this lesson is recorded for control and quality purposes. You'll receive the recording at the end of this lesson. Okay, you will receive the recording at the end of this lesson, and then you can watch again and then try these questions again. Move on. Okay, the next one that they gave to the kids in the preparatory of 2023 last year was the following sequence is an arithmetic sequence. Calculate the value of p. So they gave the sequence 1 minus p, and then they gave 2p minus 3, and then they gave p plus 5. And they said this sequence is what? Is an arithmetic sequence. It is what? An arithmetic sequence. Calculate the value of p. What do we do here, Nombuso? What do we do here, Nombuso?
Say we calculate for UP.
Yes, we need to calculate the value of p. Yeah.
Using
how?
Using arithmetic formula.
Yes, so we know that T2 minus T1 must be T3 minus what? Minus T2. What is T2? 2P minus 3. What is T1? 1 minus P. T3 is P plus 5 minus T2. T2 is 2P minus 3. And this is 2P minus 3. You multiply, which is minus 1 plus P. And then you have p plus 5. You distribute here is minus 2p plus 3. You collect like terms together. Right, which means you have 2p together with p, which is going to give us exactly 3p. Minus 3 minus 1 is a minus 4. P minus 2p is a minus p. 5 plus 3 is what? It's exactly 8. And then you collect the like terms, getting exactly 3p plus p, which is equal to 8 plus 4. What is 3p plus p? It's actually exactly 4p. 8 plus 4 is what? Is 12. You divide by 4 both left and right, getting p is equal to 3. So p equals 3. Where's the question? Because we have to calculate the value of p, and to calculate the value of p, we use T2 minus T1 equals T3 minus T2. Why? Because it is an arithmetic sequence. In the arithmetic sequences, we know that the common difference is always T2 minus T1, but also the common difference is actually T3 minus T2. And this is true for arithmetic sequences. Who does not understand what we've done here? Who is lost? Where's the question? Where's the question? Okay, they're asking a question here. Write down the value of the first term of the sequence. What is the first term of this sequence? What is the first term? We need the value of the first term. So the value of the first term of the sequence, it must be a number. What is the value of the first term of the sequence? Pegalelo. What is the value of the first term of this sequence? What is the value of the first term of this sequence? Pegalelo.
Just give me a minute, sir.
Okay. Because each time I'm giving a chance to think, I'm giving a chance to practice. So I want you to write down the value of the first term of the sequence. What is the sequence? The sequence is the 1 minus p, 2p minus 3, and p plus 5. But write down the value of the first term of the sequence. What is the value of the first term of this sequence? The value of the first term of this sequence. What is the value of the first term of this sequence?
Sir,
Yes,
it is -2.
it is -2. How do you know?
Okay. The thing that I did say, I okay, I said T1 is equal to 1
T1.
yeah,
T1 is
equal to
equal to
1
1
minus
minus P. Well done, because 1 minus P is the first term. 1 minus P is the
yes,
first term. And therefore, but you know that P is what? P is what? P is 3. And then 1 minus 3 is minus 2. 1 minus 3 is minus 2. So that it means that T1 is equal to minus 2. So the first term of the sequence is minus 2. The first term of the sequence is minus 2. What is the common difference? What is the common difference? Anyone? What is the common difference? Who knows? What is the common difference? What is the common difference? Pegelelo, what is the common difference? You'll forgive me if I pick your name. I'm just interested in making you think a little bit, you know? I want you to practice a little bit and think. It's not that I'm just picking on you, but what is the common difference? Pegalelo, what do you think the common difference is? What is the common difference? What is the common difference? Pegelelo. What is the common difference, Pegelelo?
So can I try it?
Yes, please.
It's 6.
How do you know?
Okay, say I said 1 minus, then I substitute 3.
You substitute 3.
That
Yeah,
yes. Then
yeah,
it
you're right.
gave me -2.
Yes.
Then I go to the next one, which is 2p. Instead of
Yes.
P, I substitute and minus 3,
Yes.
uh, which gives me
Yeah, I
which gives me
understand.
3.
Yes. And then the last one is P plus 5. And then you know already that P is equal to 3, isn't it?
Yes,
And then 3 plus 5 is 8.
8.
Right. And
Yes,
upon careful examination of that one, so you need to find the common difference. And so the common difference is D, which is T2 minus T1. And T2 is what? T2 is 3. T1 is what? T1 is minus 2.
this one. Oh, it's yes.
It's
Okay.
5 though.
Yeah. So, yeah. What do you think? Okay. So T1 is minus 2 because 1 minus 3. What is 1 minus 3? Is minus 2, isn't it? So
Yes.
now you have now if you put the P equals 3 here, you have the 3 and the 8. So T2 minus T1, T2 is 3 minus T1. T1 is actually minus 2. So that you have minus 3
Therefore,
plus
it's
2 because
5
negative times negative is what? Is positive. So that 3
is
plus
positive.
2 is a 5, right? Okay. So now it appears that our D is equal to what? Is equal to 5.
5.
Meaning you can come here and say the common difference is 5. You can come here and say the common difference is what? Is 5. Okay. The common difference is 5. Then, okay, we've found the rest of these things, but let us continue. We found that the common difference is 5, but we found that the first term itself, you're able to get the first term because you got that P was 3 from the previous question. And then the first term is 1 minus P, which is 1 minus 3. 1 minus 3 is what? Is minus 2. Okay, so that then in the end, if you want to explain why none of the numbers in this arithmetic sequence are perfect numbers, so that then in the end, explain why none of the numbers in this arithmetic sequence are perfect numbers. Who knows why? Who knows why? I know this one is going to be tricky. Let us save time. So you're going to have 1 minus P, and then you have 2P minus 3, and then you have P plus 5, because some of you do not know perfect squares. Excuse me. Okay, what is a perfect square? Do you remember what perfect squares are? I can imagine that you remember perfect squares. So that here you will come, for instance, and use 1 minus 3, and then you already know that P is 3. So wherever there is P here, you put 3. Minus 3, and then wherever there is P here, you put 3 plus 5. And then we have 1 minus 3, which is a minus 2. 2 times 3 is 6 minus 3, which is a 3. 3 plus 5 is what? 3 plus 5 is exactly 8. Right, so you have exactly that. So now we have 3 plus 5, which is exactly what? 8. Right, and therefore, this, you already know the common difference. So you can actually be in a position to continue with this pattern. So now the common difference, it means the number you add to each one. So if you add 5 to minus 2, it becomes 5 minus 2, which gives the next one, which is 3. And if you add 5 to 3, you get 8. If you add 5 to 8, you get 13. You add 5, you get what? You get 18. And you add 5 and so on and so forth. So now what we are able to immediately observe here is the fact that we can write like in this block here, it is that all the terms except T1 end in either 3 or 8, while perfect numbers or what we call perfect squares, end in 1, 4, 9, 6, 5, 0. Okay, we can see that all the numbers except T1 end in either a 3 or 8. 3, like this one, ends in 3, or 8, like the 18. While perfect squares end in 1, 4, 9, 6, 5, 0. Before the perfect square would be like the number that ends in a 5, it's a 25, which is 5 squared. So obviously you can see that this is what happens. Some end in 1, like 81, which is actually the same as 9 squared. Right, so all the terms except T1 end in either 3 or 8, while perfect squares end in 1, 4, 9, 6, 5, 0. Right, so that explain why none of the numbers in this arithmetic sequence are perfect squares. This is the explanation. This exactly is the explanation. Right, so all the terms except T1 end in either 3 or 8, while perfect squares end in 1, 4, 6, 5, and 0. Where's the question? Where's the question? Or equivalently, you can use the formula that says that Tn is a plus n minus 1 times the common difference. So that now you can take the first term. What is the first term? The first term is a minus 3. So you put it here, plus n minus 1, and then you have the common difference. What is the common difference? Right, so you find the common difference. We've seen that the common difference is 5. And then you have Tn, so this is minus 3 plus 5n minus 5, which is exactly 5n minus 8. 5n minus 8. So that then in the end, if this is exactly the case, you're able to see that this here is not a perfect, square. It's actually not a perfect square. Right, let me see. Okay, check here. The first term is minus 2 here, so you need to put a minus 2 there. So the first term is a minus 2 here. And then we have 5n, minus 2 minus 5 is minus 7. Minus 7. It's not a perfect square, this one. 5n minus 7 is not a perfect square. It's not a perfect square. So that we have to explain why none of the numbers in this arithmetic sequence are perfect squares. That's the reason, because the general term itself is not a perfect square. Where's the question here? Where's the question? And then we move on. Move on to the next question. Right. We move on to the next question. Okay, the next question is this one, 2.2. The following sequence of numbers forms a quadratic sequence. The following sequence of numbers forms a quadratic sequence: minus 3, minus 2, minus 3, minus 6, minus 11. The first differences of the above sequence also form a sequence. Determine an expression for the general term of the first differences. Right? So now, in this case, you take minus 3, minus 2, minus 3, minus 6, minus 11. And then you do this. So if you have this one together with this one, you have exactly a 1. This one together with this one, there's a -1. This one together with this one is a -3. This one together with this one is what? Is actually a -5. And then you do this. And then this one minus this one is a -2. This one minus this one is a -2. This one minus this one is a -2. So you are saying the first differences of the above sequence also form what? A sequence. Determine expression for the general term of the first differences. Okay, this one here forms the first differences. Okay. Now, these first differences, now when you're dealing with them, an expression for general term of the first differences, the first term. So when this is quadratic like this, it means that these ones form an arithmetic progression. So that the first term is A, and then the common difference becomes this one, which is -2. And an expression for the general term is going to be for the arithmetic sequence. It is A plus n minus 1 times the common difference D. The first term is 1 plus n minus 1. The common difference is -2. So that this is -2n, and this one is 2 plus 1, which gives us what? Gives us a 3, like that. So now if they're asking you here, determine expression for the general term, so you then say Tn is -2n plus what? Plus 3. Where's the question? So this one would be the expression for the general term of the first differences. Where's the question? Where's the question? No question. Right, calculate the first difference between the 35th and 36th terms of the quadratic sequence. Calculate the first difference between the 35th and 36th terms of the quadratic sequence. Where's the question? Where's the answer here to 2.2.2? Who knows the answer? Who knows the answer to 2.2.2? Who knows the answer to 2.2.2? Who knows the answer to 2.2.2? Nombuso. What is the answer to 2.2.2, Nombuso? Where's the answer to 2.2.2, Nombuso?
Say,
Yes?
okay. I think, say, we are going to first calculate for 35. Okay. We have our n, which is 35.
Yes?
Then we will first calculate for our like our n.
Okay.
Angithi sekuthi n, angithi sekuthi n they give us 35. It
Yeah?
will be T35 is equal to A, which is 1, plus we calculate for n, then -1 times 2. Then we also do go 36.
Yeah? Okay, I hear you. I hear you. I hear you. Yes, I hear you. Okay, so this is the trick that the examiners use all the time. Please learn this trick. Because now we are dealing with the first differences, which is this. First difference, these are the first differences. Now, this one is T1. What is term number 1 here? Is the difference between which term and which term? This one is term number 2. Term number 2 is the difference between which term and which term? So term, yes. Term number 1 is the difference between which term and which term?
Term 2 and term 3.
Yes. So this term 2 is the difference between term 2 and term 3. So in other words, term 2 here is the difference between this term 2 is the difference between term 3 and term 2. What is term 1? Term 1 is the difference between term 2 and term 1. Now, this one, this minus 3 is term 3. Term 3 is the difference between what and what? Term 3 becomes the difference between what? Becomes the difference between term 4 and term 3.
Something.
So when they say that, calculate the first difference here between the 35th and 36th terms, right? So it is the 35th and 36th terms. So you will say T36 minus T35. That is the difference between 35th and 36th terms. So now, if the difference means that difference means you need to what? You need to subtract. Difference is the result after subtraction. Are we together? So right now, if it's the difference between 36 and 35th terms is T36 minus T35. But in the case of this, because here if it's T4 minus T3, it is T3. These things are the same, but the 4 is bigger. T2, the difference between T3 and T2 gives you T2. So this one, T36 minus T35, like T2 minus T1, gives you T1. Are we together? So that
No.
T36 minus T35 would give you T what? Because these things are always the same. T1, T1, then there's a T2 there. Then the T3 minus T2 gives you T2. So T36 minus T35 is going to give you T what?
35.
It's going to give you T35.
Hmm.
Give you T35. Okay, this is the trick the examiners use here. So it means that you just, if they say the difference, if they say the difference between term 3 and term 2, it is term 2. The difference between term 2 and term 1 is term 1. The difference between this one and this one is term 2. Is the difference between term 3 and term 2. It is term 2. So now, for this one, the difference between T35 and T36 is actually T35 here. So what is T35? Because Tn is this one. Tn is what?
Minus 2 plus
Is minus
3.
2n plus 3, which means that
Yes.
you just need to get T35 here. The T35 is the difference between the correct ones. So you then say T35. T35 is minus 2 times what? 35 plus 3. What is minus 2 times 35? It's minus 70 plus 3. What is minus 70 plus 3? Minus 67. Minus 67. And the 67 is the correct answer. So you don't need to think too hard. Right.
9:30.
Okay, good. So now this is actually minus 67. Okay, learn the trick they use in the exam when you are dealing with quadratic sequences, but also now dealing with the first differences, but also dealing with what? With what you call the second what? The second differences. All together. Okay, yeah, learn the trick. Remember that this lesson is being recorded for control and quality purposes. You will get the recording at the end. But we are moving on because I want us to do a lot of the questions in this paper. And the paper is very long. So we know very well that we're not going to finish this whole paper, but we want to do the most we can. Let's move on. Let's move on. Determine an expression for the nth term of the quadratic sequence. What is the expression for the nth term of the quadratic sequence? How do you do that one? Okay, because we're dealing with a quadratic sequence here, you write minus, you have minus 3, you have minus 6, you have minus 11. Then you would find the first differences like this. What is minus 3 minus 2 minus into minus that? You get exactly a 1. Minus 3 minus into minus that. You get a minus 1. Minus 6 minus into minus that. You get a minus 3. Minus 11 minus into minus that. You have a minus 5. And you do this. This minus that is a minus 2. This is minus 2. And this is minus 2. So here you have the second differences. You have the second what? Differences. Here, these ones here are the first differences. Right. So these ones here are the first differences. Now, you continue. Determine an expression for this. So you remember that 2a is equal to this one. 3a plus b is equal to this one. A plus b plus c is equal to this one. So you come here and then say the 2a is what? Is minus 2. Okay, I would lost Nombuso there. Okay, if we lose you, please try to connect again because it might just be network issues. You divide by 2 and then you have a is minus 1. The next thing you're going to do is that you have 3a plus b is 1. And then you have this is b is 1, which means that the b is equal to what? Is equal to 4. Right, when you get that b is equal to 4, you need to get c also to be able to find the expression for the nth term of the quadratic sequence. So, which means that you're going to have this one, a plus b plus c is equal to minus 3. So a plus b plus c, you are dealing with the quadratic sequences, right? So the a is minus 1, the b is a 4, plus c equals negative 3, and then we have c equals, what is minus 1 plus 4? Is actually a 3. A minus 3 minus 3 becomes what? A minus 6. So that in the end, we have Tn equals an squared plus bn plus what? Plus c, which means that we have Tn equals, what is the a? Is minus n squared. The b is actually a 4n, and the c is what? Is a minus 6. So you have to determine an expression for the nth term of the quadratic sequence. That is the expression for the nth term. The expression for the nth term has what? Has exactly right. It is exactly what? It is exactly this particular formula here. That is the nth term of the quadratic sequence. Please think about it and think very, very carefully. And that is what you have there. Then now we move on to the next question. Right, and moving on to the next question, we're gonna do the next one. You're gonna do the next one. Show that the sequence of numbers will never contain a positive term. Show that the sequence of numbers will never contain a what? Will never contain a positive term. Right, so now to do that, you're gonna do 2.2.4, which means that what we have here is Tn. We got the general formula, the nth term, which is minus n squared plus 4n minus 6. The Tn is minus n squared plus 4n minus 6. That is the nth term of the quadratic pattern. Right, so we have here the minus n squared plus 4n minus 6. Okay, so now to be able to find the general expression, you need to factor out the negative. And then you have n squared minus 4n plus 6 minus. So that in the end, you have n squared minus 4n. Then you need to complete the square here. You do that in grade 11. So you have the minus 4, you divide by 2. You take the coefficient of the n. We spent a bit more time some time back on completing the square with Pekalelo, right, in the grade 11 learners. So that now at this point, you have n squared minus 4n, and then you have plus, you have minus 2, you square this, and then you have minus 2, you square that, and then you have plus 6 like that. Okay, and then now at this pointer, you have Tn, which is minus. Okay, at this pointer, then you have n minus 2. Right, so you have this negative 2, then this one, this trinomial here, you can just factor it by writing the n and the minus 2, and you put a square on top, minus, you square the minus 2, you get exactly a 4 plus 6. Right, and then you have the Tn equals, and then you have n minus 2, you square this, then you have 6 minus 4, you get a 2. You distribute, and then this becomes exactly n minus 2. You square this, which becomes minus 2. But obviously, see, by looking at these in the 2.4, the Tn, which is n minus 2 squared minus 2. So that then in the end, you'd realize, therefore, that show that the sequence of numbers will never contain a positive term. Right, you would therefore realize that there is a T max term. Right, so Tn max. So that the Tn max is going to occur when at n equals 2. At n equals 2, this one is going to be 0, so that we have minus 2. So that we have minus 2. So that the Tn max, therefore, is exactly what? It's exactly minus 2. And the maximum term is minus 2. That is the biggest one, which is going to occur when n is 2. And as a consequence here, you say then, therefore, no positive terms. No positive terms. Because the maximum, the biggest one, is a negative 2. Meaning the others are going to even be much more smaller. So as a consequence, therefore, this particular sequence will never contain a positive term. Where's the question? Where's the question? Okay, try to think about these things. You watch the video during your own leisure. Make sure you can make sense of these calculations, and make sure you understand these things. We're trying to train you to deal with the September assessments. These September assessments are very serious. So you need to be able to think big. You need to be able to analyze the questions. If ever the network is breaking, please, you will have a chance. This lesson is recorded for control and quality purposes. So you'll have a perfect chance to understand the things as we move along. We move on. Okay, now let's look at 3.1. Let's look at 3.1. Given that Sn is 4n squared plus 1, determine T6. Determine T6. Okay, T6 is the 6th term. So parallelo and nombuso. Right, we're given Sn equals 4n squared plus 1. Determine T6. They're saying if Sn is that one, then T6 is equal to what? What do we do here? So if Sn is 4n squared plus 1, then what is term number 6? What is term number 6? What is term number 6?
Sir, can I try?
Yes, please.
145.
How do you know? How did you do it?
I substituted 6 at n.
Okay, you substituted 6 and then you got S6, which is 4, and then you have 6 squared plus 1. And then it is 4 times, and then you can use a calculator to save time here. 6 squared. 6 squared is 36 times 4 plus 1. So we're going to have here, okay. We're going to have 4 times 6 squared plus 1. What's the answer? It's 145, okay? Yeah, okay, you got 145, that's fine. So for instance, you have here exactly 145. Then you also have now S5. You must also do S5. I'll tell you why. And then you have 5 squared plus 1. What is S5? Now 5 squared is what? It's 25. 25 times 4 is what? Is 100. Plus 1 is what? Is 1.
101.
Good. Thank you so much for being in a position to do that. So now, if you want to find term number 6, because you're saying determine term number 6, this is the sum. So this one says the sum of 6 terms. The sum of 6 terms, the sum of the first 6 terms is 145. The sum of the first 5 terms is 101. So T6, therefore, is the sum of 6 terms. From the 6 terms, you minus the sum of the 5 terms. So if from 6 terms you remove 5 terms, then you are left with term number 6. Right. So as a consequence, then you have term number 1, you have term number 2, you have term number 3, you have term number 4, you have term number 5, and then you have term number 6. Okay, you have those particular terms there. And we are then saying, out of these 6 terms, these are 6 terms, you minus 5 terms. You minus the first 5, you minus this, you minus this, you minus this. If you minus this, then you are left with what? You are left with term number 6. So that then term number 6 is just all the 6 terms, and then you minus only the first 5. So now you have the sum of the first 6 terms, which is 145. And then the sum of the first 5 terms is 101. Out of the 6 terms, you remove 5, you're left with the term number 6. So that 145 minus 101, what you get is the answer. You get exactly what? A 44. You get exactly a 44. So that T6 is equal to a 44. Who has a question? Because it was like 3 marks in last year's paper. 3 marks. So to get T6, then you must say S6 minus S5. So we continue. We continue. For which values of X will the following series converge? Okay. So how do you do convergence? This 3.2. For which values of X will the following series converge? If they give you 4x minus 3 plus 4x minus 3 squared plus 4x minus 3 cubed, for which values of X will the series converge? How do you do this question? Okay, convergence, you must do what? To do convergence, you must find the constant ratio. So how do you find the constant ratio? Pegelelo. How do you find the constant ratio? How do you find the constant ratio, Pegelelo? How? Okay, to find the constant ratio, which you call R, the constant ratio is always term 2 divided by term what? Term 2 divided by term 1. That is the constant ratio. Term 2 divided by term 1. So that term 2 is what? Term 2 is 4x minus 3, which you square, divided by term 1. Term 1 is 4x minus 3. And then if you divide this, you get 4x minus 3. So that for which values of x will the following series converge? Right, it will converge whenever for convergence. Right, for convergence. What do we know for convergence? For convergence, minus 1 must be less than r less than 1. So that now we have minus 1 is less than. The common ratio would be 4x minus 3 is less than 1. Right, so you need to solve for x here. To solve for x here, now you need to add 3 here. Less than 4x minus 3, you add 3 here. And this one is plus 3 there. So minus 1 plus 3, you get 2, which is 4x less than 1 plus 3 is what? It's a 4. And then you want to solve for x. So to solve for x right now, you want to remove this 4. And to remove this 4, you must multiply by 1/4. 1/4 times 2 is less than, you have 1/4 times 4x, and then is less than, and then you have 1/4 times 4, which means that now you have 2 over 4, which is 1/2 less than x less than 1. And therefore, this is the answer. This is the answer. So that 1/2 is less than x less than 1. 1/2 is less than x less than 1. But you must indicate that, because in the end, then you must also make sure that the 4x minus 3 is not equal to 0, which means that x is not equal to 3 out of 4. So that x indeed lies between 1/2 and 1, but you're effectively then saying that x is not equal to 3 out of 4, because 3 out of 4 is 0.75, and 0.75 is actually surely between the 0.5 and 1. 0.5 and what? And 1. 0.5 and 1. You get the point? So, for which values of x will the following series converge? This is the answer. You must first get what you call the constant ratio, and then we're using T2 over T1. But also the constant ratio is not only T2 over T1, but it's also T3 over T2. Right, but also it's going to be the same thing, because if you do T3 is 4x minus 3, you cube it, and then T2 is 4x minus 3, and then you square it. If you divide these things, you have 4x minus 3. And this is the what? This is the constant ratio. And the constant ratio is -1, between -1 and 1. Then if you have the 4x minus 3 is between these two, then you're able to get that x is between 1/2 and 1. Please ask if you have a question. Any question about the values of x for which a series is going to converge? They're going to ask you this question, please, in the exam. It's already there. It's already there, Nombuso. This question is already there on Friday. It's already there in the exam. Pegelelo, this question is already there in your September test. It's already there. This one is already there. As it is there already. They're going to ask you, for which values of x will the following series converge? They're going to ask you. Okay, we move on. Now let us look at 3.3. Calculate this sum here. Calculate this sum here. So how do you calculate this sum? To calculate this sum, we are dealing with the summation. Right, from k equals 3 to k equals 5, and we're dealing with the summation. Right, from k equals 3 to k equals 5, then you have -1 to the power k, and then you have 2 out of k. And then you're going to substitute everything here. You're going to substitute everything. So if you put k equals 3, then you're going to have -1 to the power 3, and then 2 out of 3. And then plus -1 to the power 4, 2 out of 4, plus -1 to the power 5, then 2 out of 5. All right, so we have -1 cubed, which is -2 out of 3. Then -1 to the 4th power, which is exactly 1. So we have 2 out of 4 there. But if you raise -1 to an odd number, it's going to be minus. So it's -2 out of 5, and then you add everything here. If you add everything here, you take the LCD. What is the LCD here? Right, what is then the LCD of this? It's 30. So 30 divided by 3, it's exactly a 10. You multiply here, you get -20. You divide 30 by 4, right? Or you use a 60. Just use a 60. Right, so if you use the LCM 60, you divide 60 by 3, you get a 20 times 2 is a -40. Divide this one by 4, you get a 15 times 2, you get a 30. Right, you divide 60 by 5. Right, so if you have 60, you divide it by 5, is the same as 6 by 10 out of 5. You divide this, getting a 2, which gives you 12. Right, times 2, which gives you -24. Okay? And therefore, now at this pointer, you have exactly a 30 and the minus -64. Right, so what is 30 minus 64 is actually minus 34. You divide by 60 and you divide this one by 2 and it becomes exactly minus 17 out of 30. So obviously you need to calculate this sum here, and this sum here is minus 17 out of 30. How did you do that? We evaluate this from k equals 3 to k equals 5. And then now wherever there is k, you put 3. You put 3, 3. And then next, the 3, this k runs it from 3 to 5. Right, so from you put 3, 3, then you put 4, 4. Then you stop at 5, 5, and then you add all the numbers. Where's the question about this summation problem? Where's the question? And this summation is said to be in what? Is said to be in sigma. Sigma notation. It is in sigma notation. Where's the question on this one? 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 Let's move to the next question. Let's move to the next question, because I want us to do as many questions as possible. We're not going to finish the paper because time is running. But now let's look at question 4 that was set last year for the kids. Consider the graphs g of x equals 6 over x plus 3 minus 3 over 2. H of x is 6 over x minus 3 plus 2. Write down the domain of G. Who knows the domain of G? 1 mark. What is the domain of G? What is the domain of G? What is the domain of G? How do you find the domain? What do you look for in the domain? Okay, to find the domain, you just look for the denominator. You look for the denominator if this one, and then you just say x plus 3 is not 0. So the domain means that the denominator cannot be equal to 0, and that means that x is not equal to what? Is not equal to minus 3. That means that x is not equal to minus 3. Then now you're going to do 4.2. Write down the range of h. Write down the range of h. Who knows the range of h? Nombuso, what is the range of h? Nombuso, what is the range of h? Okay, h is this one. Yeah, h is 6 over x minus 3 plus 2. What is the range of h? I've just copied this h here. What is its range? What is the range of h?
Its x is equal to 3.
Okay, so the range is to do with the last number. Right, so the range would be y not equal to 2. Y be a real number. So here for the domain, you say x is not equal to minus 3. So for the domain, you say x is not equal to minus 3, yet x is what? Is an element of the set of real numbers. So x is an element of the set of real numbers. X is not equal to minus 3. If the graph of G is shifted so that it coincides with the graph of H, so the graph of G is shifted so that it coincides with the graph of H, how many units must the graph be shifted horizontally? Okay, so they've given you two graphs. The graph of G is 6 over x plus 3 minus 3 over 2. The graph of H is what? Is 6 over x minus 3 plus 2. If the graph of G is shifted so that it coincides with the graph of H, how many units must the graph be shifted horizontally? So we are saying that the graph of G is shifted horizontally so that it coincides with the graph of H. How many units must it be shifted horizontally? Who knows? Pegelelo. Pegelelo. Are you able to see the question? We're saying this graph of G is shifted so that it coincides with the graph of H. How many units must the graph be shifted horizontally? How many units must the graph be shifted horizontally? How many units must the graph be shifted horizontally?
So is it 1,5 units to
How do you
the
know? How do you know?
front?
How do you know?
So I look at the equation.
You look at the equation. Okay, because now the horizontal shift is going to affect, horizontal shift affects the x-axis, and then the vertical shift affects the y-axis because the y-axis is vertical. So if you shift horizontally, so the x plus 3 must be the same as what? Must be the same as x minus 3. X plus 3 must be the same as what? X minus 3. X plus 3 must be the same as what? X minus 3. You get the point?
Yes.
The question is, what number can you add now? We want to make x plus 3 to be the same as x minus 3. What number do we add here so that it looks like this? So that x plus 3 is x minus 3. What number do we add to plus 3 so that plus 3 becomes minus 3? What number do we add there? This will be a shift horizontally. This should be a horizontal shift.
So we should add.
Yes. Or subtract. Add or subtract.
If we're adding, we have to add -6
We need to add -6.
to.
That's correct. We need to add -6 plus 3 so that -6 plus 3, you get -3. And this is the horizontal shift. So it means that the horizontal shift must be 6 units. 6 units. But you see, if you subtract 3, it means that it is 6 units right. 6 units to the right. Okay, right. So if it is 6 units to the what? 6 units to the right. You can write like that. It is 6 units to the right. Okay, so that now the x plus 3 is going to be like x minus 3. 6 units to the right. That's a horizontal shift that is going to change the x to make the x plus 3 like x minus 6. Then how many units must the graph be shifted vertically? Okay, so now if this graph is shifted vertically, it means that we have -3/2. -3/2 must be made the same as what? Must be made the same as 2. So what must be added there? -3/2 must be made the same as -2. What do we add to -3/2 to get 2? Who knows? Who knows? There's a number we can add here. There's a number we can add or subtract. There's a number we can add or subtract to this so that we get 2. What number do we add here to get 2? Anyone? Who knows? Who knows? What number can you add to -3/2? You see, -3/2 is the same as what? -3/2 is -1.5. -3/2 is -1.5 because this gives 2, like that. -3/2 is the same as -1.5. So what number do we add to -1.5 to get 2? There's a number we need to add, or a number we need to subtract. What number? Nombuso, what number? What is the number?
Sir?
What number
It's
do we add?
parallel.
Yes, Pechalelo. What number do we add? Because they're saying how many units must the graph be shifted vertically? For the vertical shift, you just look at this number here. And then
So we can add.
yes, what can you add?
We can add 3.5 to
You
get
can add
2.
3.5. Well done. We can add exactly 3.5 because I'm just testing you with these things, guys. So you can add 3.5 because if you say 3.5, 3.5 minus 1.5 is 2. So this means that this one here, you can say it is 3.5 units. Because by how many units? It is 3.5 that can be added. So it's 3.5. But this 3.5 it's a plus. It's positive that you're adding. It's a positive number that you're adding. So it is 3.5 units upwards. Because if you add the graph goes up. The graph goes up. You see, I'm just testing you with these things because I just need to make sure that you can just use your heads a little bit. Right. Okay, we move on. Next question. Next question. Okay, write down the equations of the asymptotes of G. Okay, if we say that G of X is 6 over X plus 3 minus 3 over 2, what are the asymptotes of this G? Nombuso. What are the asymptotes of this G? Nombuso.
So can I try? Oh, okay, it's fine.
Okay, anyone?
Okay.
Yeah? What are the asymptotes of that graph there? Nombuso.
Okay, so I was going to say it will be
Yeah?
3
It will be 3.
2 3 over
So
2.
it will be 3 over 2, huh? Like
Mhm.
the minus 3 over 2 is y, and then the x plus 3, to get the asymptote for the x plus 3, you must say x plus 3 is 0. So that x is minus 3. Or y is minus 3 over 2. Okay.
Okay, fine.
So now what are the asymptotes? The asymptotes, this one is called the vertical. It's called the vertical asymptote. And this one is called the horizontal. It's called the horizontal asymptote. It's called what? The horizontal asymptote. Right, if you look at 4.5, calculate the x-intercept of G. What is how do you find the x-intercept of G? What do we do? Because G of X,
Let
yes, what do we do? Anyone?
sir
Okay, yeah. We're looking for the x-intercept.
for the y-intercept,
Yes.
let y equals to 0.
So we need to let y be equal to 0. Because we need to get
Yes.
the x-intercept, you let the other variable be 0. To get the x-intercept, you let y be equal to 0. When y equal to 0, it means that wherever there is G, you're going to put 0 like this. Minus 3 over 2. And then it is 3 over 2, which equals 6 over x plus what? X plus 3. You cross multiply this so that you have 3 by x, which is exactly 3x plus 9, which equals 2 by 6. 2 by 6 is what? Is 12. And this is 3x equal to exactly 9 minus 12 minus 9. 12 minus 9 is what? Is 3. So that we have 3x equals 3. We divide by 3, we divide by 3. So that x is equal to what? X is equal to 9. X is equal to 9. Okay, so this is the x-intercept. How do you write the x-intercept? So the x-intercept is, we have already got that x is equal to 1. Right, so if x is equal to 1, then it means that you can just write here x is equal to 1 and then y is equal to 0. Y equals 0. And that is the x-intercept of G, is 1 and 0. Is 1 and 0. Where's the question? Where's the question? So we found the x-intercept of G. We move on. Next question. Next question. Okay, consider the graphs of that. Sketch the graph of G in your answer book. Show clearly all the intercepts there. Right, so to sketch the graph, it's very straightforward. We're going to sketch it very quickly. This is the x-axis and that is the y-axis. But we've seen that now the graph of G has a vertical asymptote through -3. And the equation is x equals -3. And then we have already found the x-intercept of the graph. And then the x-intercept of the graph, it's going to become what? It's going to be 1 and it's going to be exactly 1 and 0. So that's going to be exactly the x-intercept of the graph. But we've seen that the y-intercept of the graph, the horizontal asymptote is y equals to this one. So, which means that this is the graph. So it's going to have its y-intercept. So for the G, the y-intercept, right? The y-intercept is obtainable whenever x is 0. Which means that you have G of 0, which is 6 over 0 plus 3 minus 3 over 2. Which means that G of 0 is 6 divided by 3, which is 2 minus 3 over 2. And 2 minus 3 over 2. 3 over 2 is 1.5. From 2, you remove 1.5, you get a half. So it means that this one is going to be whenever x is 0, y is 1.5. It's going to give us exactly the y intercept. Now, G of x is 6 over x plus 3 minus 3 over 2. And therefore, it means that you're going to have exactly this one here. You're going to have exactly this. So that in the end, then if this graph is like this, you would have exactly this graph. You'd have exactly this graph. One piece is going to be there and the other one is going to be this way. Right. Show clearly all intercepts and show clearly all asymptotes. The asymptotes we have shown. And then also this is the horizontal asymptote. That is the vertical asymptote. The y-intercept is shown 0 and 1/2. The x-intercept has been shown is 1 and 0. And we have pieces of the rectangular hyperbola appearing in the Cartesian plane. Where's the question? Where's the question? Right, we move on. Next question. Next question. Right, so in the next question right now, we're going to be looking at 4.7. Determine the value of k if h of x is minus x plus k. Right, determine the value of k if h of x is minus x plus k is an axis of symmetry of G. Determine the value of k if h of x is equal to minus x plus k is the axis of symmetry of G. So how do you know about the axis of symmetry of G? So the axis of symmetry of G is going to be, the axis of symmetry is going to be such that it's going to be, the axis of symmetry is going to pass through, and axis of symmetry passes through the intersection of the two asymptotes, right? The horizontal asymptote and also the vertical asymptote. Right, so that at this point, you have the intersection -3 minus 3 over 2. Y is minus 3 over 2, minus x. And then x is minus 3 plus k, which is 3 plus k. What is k? K is going to be minus 3 over 2 minus 3, which means that k is minus 3 over 2 minus 3, which is minus 3 minus 6, which is minus 9 out of 2. So obviously here we need to determine the value of k if that is the case, but we've already seen therefore that k is actually equal to what? K is actually equal to minus 9 out of 2. Right, so this allows us to determine the value of k if that one is an axis of symmetry of the graph. right? And therefore K is minus 9/2. Okay, you know that there are two lines of symmetry of the rectangular hyperbola. It is either the one which is minus x plus k, or you do x plus k. I can see the time. Okay, for which values of x will this one? For which values of x will the 6 over x plus 3 minus 3 over 2 be greater than minus x plus k? Right, so obviously at this point you need to have a rough idea of the graph, so that you have this, and then you have this, right, and then you have this, minus 3 out of 2, y, and then this is x. Right, so we have seen that one of the pieces of the graph is going to be like this, and the other one is going to be this way. So that then in the end, what we're getting here, for which values of x will this one be the case? So for which values of x will the rectangular hyperbola for G, this is the graph of G. So for which values of x will the rectangular hyperbola for G? So we're saying G of x here is bigger than minus x plus k. Right, so if G of x is bigger than minus x plus k, it actually means that this particular graph here, the G is going to be bigger than so G is above the line of symmetry. So the line of symmetry with the negative slope will actually be the line of symmetry that runs straight down like this. So here effectively we're saying that G is above this line of symmetry. So for which values of x will that be the case? So now you need to look and think and reason very, very carefully. So at what point we have that the G is above? Right, and you're able to see therefore that whatever, because this is minus 3, this is minus 3. So you'd actually be in a position to realize that at this point it will be when x is bigger. It should be when x is bigger than minus 3. Right, so whenever x is bigger than minus 3, you'd realize that indeed this graph will be most certainly. So in other words, when you progress in this direction, you'd actually be rest assured that there's G is above. Otherwise, here, obviously, what then we are seeing is a potential point of, okay, there's something else I want to say here. So because if you look at the 6 over x plus 3 minus 3 over 2, and we're saying it is actually above the minus x plus k. So we're saying G is above that. So I want us to look at the fact that G here, for instance, G here is below. G here is below, and want G to be above. So G is surely above when x is bigger than minus 3. Because if you progress in this direction, G is above, and here G is below. Think about it. Okay, now the graph of G is reflected in the x-axis. The graph of G is reflected in the x-axis. Now in 4.9, the graph of G is reflected in the x-axis. Okay, you reflect it in the x-axis. This is the x-axis. You reflect the graph of G. Write down the new equation in the form y equals something. So this is bigger than minus 3. The graph of G is reflected in the x-axis. Yeah? Write down the new equation in the form that. So if you reflect, so now there's something we call a reflection. Reflection in the x-axis. Okay, look. A reflection in the x-axis, this is the sort of graph. Okay, a reflection in the x-axis would mean a point here would have its image there. That's how you reflect in the x-axis. So a point xy would be that y is negative. If you reflect in the x-axis, y is positive here, and then y becomes negative below. So if you reflect a point xy in the x-axis, reflection in the x-axis is going to make y negative. Going to make y negative. Okay, so now you're going to Now the graph of G is reflected. This is the graph of G, right? Which means that at this pointer, you're going to consider G of X, which is 6 over X plus 3 minus 3 out of 2. So so at this pointer, then Y is going to be negative. So if Y is negative, then you're going to have negative Y, which is 6 over X plus 3. But X remains the same. If you reflect in the X-axis, then Y becomes negative. Because Y is positive here, then Y is negative below. You divide, which means it is minus that over X plus 3, and then plus 3 over 2. Okay, so now write down the new equation. This is the new equation. That is exactly the equation. Okay, if you reflect in the what? You reflect in the x-axis, it means that y becomes negative. Y becomes negative, so think about it. I'm going to make this video available immediately after we're done with our discussion so that you can watch the video and practice with these questions and repeat. You watch this video, you play back. This video is going to be there for the longest of times. It's going to be there for a very, very long time. Right, now the time is exactly after 10, 21 past 10. I think that you need to stop because your minds are tired now. Your minds are tired because you see, we have a lot of questions and there are some other graphs there. But I think that is some good time for us to actually stop. I must thank you guys for joining us. It was awesome having our discussion. We shall be right back tomorrow at the same time, 8 p.m. And we shall be doing more questions. Right, thank you for joining us. The best is we start early and we can run through many, many questions if possible. But again, I mean, in the end, it's very important to understand. So it's not a question of just having a marathon, running through the questions, but also the understanding is very important. Right. I must thank you guys for joining us. It was awesome having this discussion. Until tomorrow, take care. And I'm going to make this recording available tonight to you. I'm going to send it to you. But thank you guys. Take care and goodbye. Goodbye, Pegelelo.
Bye, sir.
Goodbye.